This meeting is being recorded.
All right. So this is the poster design for our compact 5-volt power supply for our analog electronic final project. I am Grant Powell, and this is my team member, Abdullah Alnajrani. I'm sorry if I mispronounced that.
No, it's good.
Abdul will start out by introducing the summary of our project and the project goals for our project. So Abdul, take it away.
Yeah, okay. Actually, I will talk about the summaries. For the summary, for this project, we designed a 5-volt power supply with the use of an X-rated capacitor instead of a Berkeley transformer. The reasoning behind this is to cut back on the size of the unit and the cost of the unit. That is the summary. Yeah, and I want to talk about the project goals, and the project goals. For this goals of the project, we simply wanted a small form factor that is cheap and different at producing power.
Yep.
Yeah.
Thank you, Abdul.
You're welcome.
All right. So for the assumptions for this project, we just assumed regular resistance values. When measuring them, they were slightly off from our simulation assumptions, not to a large degree, not to affect any matters. One problem we had with the assumptions is we were going to use a 470 kilo ohm resistor to absorb the extra power, but we didn't have one available to us, so we used a 500 kilo ohm resistor instead. I'll talk more on that later. But for the research outline, we looked on Google Scholar and looked for other designs for a transformer-less power supply and see how they did it. We got quite a few. One we got was from the IJIST, the Innovative Research in Technology and Science Journal, and it did a great job outlining all the different benefits and changes that a X-rated capacitor power supply setup will do for us. So mainly that article was the big source of our knowledge for this project. For the hardware design process, we started out with a multi-sim simulation. It was pretty basic. It just involved simple circuitry and used a oscilloscope and a voltage meter in the simulation to confirm our results for the actual design of the power supply. The way we actually built the power supply and the way it works is that it starts with an input of 220 volts AC power, and then that goes into our stage 1 of the power supply, which is the X-rated capacitor with the first resistance, 470 kilo ohms. This is to shunt down the current to a more manageable level for our small circuit, and the large resistance is to absorb the extra power that our capacitor will not be dealing with. After the power leaves the current correction stage, it goes to the bridge rectifier, which was simply 4 1N4007 diodes, but in a bridge rectifier formation. This converts our AC voltage to DC voltage by cutting off the negative sinusoid of that. After that, the power goes on to the next stage. It's our filtration capacitor. It's just simply a 1,000 microfarad capacitor used to smooth off the top peaks of our voltage. And after that, it is simply a Zener diode ran in Zener form to shunt the voltage down to our desired level of 5.6 volts. And after that, it's the output power, which should be 5 volts. The materials we used for this is two 100 ohm resistors, 1,000 ohm resistor, 1.1 microfarad 400 volt X-rated capacitor, a 1,000 microfarad capacitor, 4 1N4007 diodes, and 1 Zener diode, 5.6 volts is the rating on that. If you look at the bottom of our poster here, you can see our actual finished product. It is simply a cardboard box wrapped in electrical tape that houses the actual PCB circuit within there. And so when you move it around and touch it, you don't accidentally shock yourself or cause damage to the parts. At the end there, for the terminal leads on the exit, you have a standard 5-volt connector pin in case you want to power any standard 5-volt products. But we also have the terminal leads to be removable, so you can measure and plug it into more bench-like items. So for the results of this project, we did not get the desired 5 volts that we were looking for. But we instead got 3.47 volts, which is 1.5 volts lower than what we were looking for. This is because our 470 kilo ohm resistor was replacing a 500 kilo ohm resistor, and that absorbed too much power for what we needed. So not enough power was running through the system to produce the actual 5 volts. When testing, plugging it into different outlets, say for example, the outlet at my home, it produced 3.6 volts instead of 3.47. That's another factor. Since it doesn't have as many regulators in it, it is much more susceptible to the input voltage. For the conclusion of this, that our power supply did function as a power supply, but not a 5-volt power supply, more as a 3.5 volt power supply. And this is simply due to the use of the wrong resistor for R1. To fix this, it'd be simple: get a 470 kilo ohm resistor or get a 70 kilo ohm resistor and unsolder it and replace it in series with the rest of them. But it did meet the goals of being very small form factor and very cheap. The actual cost of all the components that went into the build of this was $1.32 if you bought each individual component. Of course, it was more than that with wholesale, because you can't just buy a single part. You have to buy it in packs of 10, 20. But if you look down to each part, it's $1.32 to build a 5-volt power supply. But yeah, that is our poster over our final project for analog electronics. I hope you enjoyed it. Thank you.
Yeah, thank you.